On this example, we're just visualizing if we can find the points on the graph in which the slope of the tangent line equals the average rate of change from -4 to 4. So from -4 to 4, we can do delta y over delta x to find the average rate of change. So this point is 4, 0. This is -4, -1. If I do y1 minus y2 over x1 minus x2, I would have 0 minus -1 divided by 4 minus -4. So that would give me 1/8. So that's a positive slope, right? So I have positive slopes here. Then it goes to 0. Then I have negative slopes. Then it goes to 0. Then I have positive slopes. Then it goes to 0. Then I have negative slopes. So if you go and look at book 4.2, it talks about the mean value theorem. Rolle's theorem is a special case of the mean value theorem, where if the slope of the average rate of change is 0, that just tells you there's a critical point within that interval, some point in which that slope is 0. The mean value theorem more generally is saying that there's some point C that the value of the derivative is equal to the average rate of change between A and B. So some point C within that interval where the slopes are parallel. So if you go back to this example, you see that I want to find a parallel slope here, and these slopes are changing, but I'm going from positive to 0. So it's going to be somewhere between -4 and whatever this point is. There's going to be some point within there in which this slope is the same as this slope. And then same thing from this 0 to this 0. All these slopes are negative. So there's nothing going to be in between from this point to this point. However, on the other side of this point, there is a slope in which the slope is parallel. So if I go from 0, and then it maybe starts out here, go forth. So if we look at these examples here, just visually inspecting, roughly this slope is going to be something that's going to be pretty close to whatever this slope is. If I was able to kind of move this around, if I have a point, let's see if I can draw from this point to this point, extend it a little bit. You can see that if I drag this point up, it's going to be roughly some point in between there. If I drag it up a little bit more, you can see that it's a pretty good approximation for the second and then the third here. Here it wouldn't make sense to have these points. This slope is not equal there, so we can kind of rule that out. Here, the slope here obviously is not going to be equal to the slope between these two points, -4 and 4. -4 and 4 slope, and this obviously doesn't make sense. So the only one visually that kind of makes sense is this one here. If you were able to zoom in and get a true tangent line, we'd probably have something more like this, which is going to be parallel to that. And then this tangent line here would make sense that it's parallel to the slope, the average rate of change. And then here we can also get a tangent line that's going to be parallel, roughly. So the visual inspection is just kind of connecting that idea is between these 2 points exists at least one point, and when the slope is going to be parallel to the average rate of change, where the slope is going to equal a positive 1/8. And you can do that kind of by guessing if a slope goes from a negative to a positive value, from a positive value to a negative value, it's going to be increasing, and then the maximum is going to be here, and then it's going to be decreasing. So if there's a point here, and a point here, roughly, it's not at the 0 point, to note that. It's going to be on one side or another side of that 0, depending if it's increasing or decreasing. So the visual of what's going on there is kind of saying roughly where that point exist. Algebraically, you're going to go and find that point by taking the derivative and setting it equal to the same slope to find the exact point. So if this is the average rate of change between the two black points, then there exists at least one point in between in which the slope is equal to the average rate of change. When you have some values of a function, or if you have the function explicitly, you can take the derivative, set it equals 0, and find those points. And the special case of mean value theorem is just Rolle's theorem when the slope equals 0. That's just a special case. Hopefully this clarifies what's going on here, and if you have any other questions, please let me know.